This is Narayana. Yeah, in last class I explained the CAN protocol, what is what, and how to start the CAN protocol, what is the importance of CAN protocol. So now I am explaining detailedly from the definition to ending part of the CAN protocol. Okay, some topics I will explain in this video. Okay, let's start the video. So today topic is a CAN protocol. What is CAN protocol here? Just I will give the introduction about the CAN protocol, and after that I will start definition and what are the important points are there, and how to understand the CAN protocol. I will explain you one by one in next slides. Okay, CAN. CAN is nothing but controller area network. It is an asynchronous serial communication protocol introduced in the year of 1983 by the Robert Bosch. Here, the CAN protocol was introduced in the year of 1983 by Robert Bosch. Um, for the main purpose of this protocol to communication between the ECUs or electronic devices between the human and electronic devices. So, in this CAN protocol is useful to in automotive domains present in mostly. So, in automotive domain, CAN protocol is used allows to engine controls, like for example if you take the engine controls or ECUs. So in these ECUs will share the data from engine RPM. Okay, engine RPM with dashboards or displays or anti-lock braking systems, so without a direct wire connection between them. For example, if your car infotainment is there, right? So in this infotainment we are seeing some uh, door signals and engine signals, RPM signals, right? And also speed controls and also anti braking systems, right? So this type of communications or this type of signals we will have in infotainmentation system. So how it will working like means the internal connection is CAN protocol. So this is the main use of CAN protocol. So let's go the next point. The CAN protocol is a message based protocol, not an address based protocol. Means it will transmitted data is available for all the nodes, and it receives choose to receive the data or not. Okay, it means it is in a message based protocol, not it is an address based protocol. It can transmit the data which is uh, which is available in all nodes. Whatever the data is presented in nodes, so it will transmitting from one receiver choice. So it will choose a receiver is data receives or not. And also, and one most important point is the CAN contains two nodes. So the CAN nodes are connected in two wires, okay, which is CAN high and CAN low, which are in a twisted pair because it will reduce the noises. So if any twisted pair of wires, it will transmitting the data, it will generate some magnetic waves through the surrounded of wires. So it will that magnetic field will destroy the noises and the disturbances from the communication. So this is a twisted pair cables to termed as an a CAN bus. Okay, it is also called as an a CAN bus to terminate it with 120 ohm resistors to prevent the reflections. Okay, I will explain this. What is the 120 ohm resistors, what is the use of these 120 ohm resistors in both ends. Okay, yeah, coming to the definition part, we can start from the CAN protocol now. Okay, in this CAN protocol, the communication protocol between the ECUs in the form of frames. Okay, it will transmit the data from in the form of frames. Here we can explain what is the frames means. In these frames, it is used to data from one node to another node, transmit data from one node to another node. For example, you are sending engine speed or RPM to the ECU, okay, to the dashboard. ECU to dashboard, you are sending RPM. So this is the remote frame. It requires the data from another node to transmit the data from one ECU to another ECU. Here, which is here the frame means, the frame refers to structured format. For example, you have some structures, right? So in this structured format used to transmit data between nodes on CAN bus, it essentially a data packet. So that follows the specific rules to ensure the reliability, reliable communication. Okay. So the what is the ISO of this CAN means? It is 11898. Okay. Who developed this? Who developed means Bosch. Robert Bosch is developed in the year of 1983, implemented in Mercedes-Benz because its most and powerful communication protocol. It was firstly used in Mercedes company and Mercedes-Benz vehicles, and dilemmas means here the most heaviest vehicles, right? The Benz heaviest vehicles and also Volvo heaviest vehicles we use there mostly in first when introducing. After that, Mercedes-Benz used this protocol. So what is the speed of CAN? The CAN speed is 1 Mbps per second. It will transmit data from 1 Mbps. 1 Mbps of data will transmit in per second. Okay. What is the length of this CAN means? 40 meters. Okay. Its length is only 40 meters. Sorry. CAN bytes. How many bytes of data it will transmit per second? 8 bytes of data it will transmit per second. CAN is a two-wire interface. I again saying that I will clarify this one on one. What is the 120 ohm resistor and also so CAN is a two-wire interface twisted pairs. CAN network consists of two twisted pair wiring between the CAN nodes, which is CAN high and CAN low. So in this CAN high and CAN low, we have 120 ohm resistors at both ends for one end and second end. So in these two ends we have 120 ohm resistance. Okay. In this 120 ohm resistance is minimize the noise and reflections of the bus. What are the reflections? Means sometimes if you are transmitting data, sometimes your signals are missing, right? When we are talking to someone, your signals are mismatching and some noises are adding in your calls, right? So same time you are when we are transmitting the data from ECU to infotainment, some noises are adding, some engine noise is adding from sometimes. So to avoiding this type of engine noise and climate noise, so surrounding noise to the transmission of ECU to infotainment. So these these 120 ohm resistors are plays a major role because the every ECU will have the so I will show you and I will explain you clearly. So this is the CAN bus. Okay, this is the CAN high and this is the CAN low. This is the CAN high and this is the CAN low. So these are the ECUs, right? So in this UCS, when we are transmitting data, this is RT 120 ohm resistor and this is one of the 120 ohm resistor. When we transmitting the data from this end to this end, some noises are adding in this node, climate conditions or engine noise, right? Vehicles are getting noise, right? So these engine noise, so every ECU will have transmitter. Okay, receiver, transmitter will have every node. Okay, every microcontroller will have transmitter and receiver, okay, or trans receiver. So in this trans receiver will have 60 ohms of impedance. So to match or parallelly to combine of these transmitter, one transmitter and second transmitter. So this ECU, this is the main ECU, you can think this is main ECU, it is the another two ECUs. So this ECU will send, wait, so this ECU will sending the data from this ECU, okay. What will happen, some noise are adding or some, right. So this ECU will have 60 ohm resist impedance, okay, impedance resistors. This ECU will also have 60 ohm trans receiver, 60 ohm impedance trans receiver will have. So to maintain these two power connections, to maintain these two power connections, to avoiding the noises or signal missings or this type of communication, we are using 120 ohm resistors. See, here I will explain how it calculate. So, according to this home, transceiver has 160 ohm resistor impedance. So, according to maximum power transmission theorem, the source impedance equal to load impedance. This is the main formula to calculate, and why we are using to 120 ohm resistor at both end. So what is the formula of this maximum power transmission theorem is R1 into R2 by R1 plus R2. This is the formula for maximum power transmission theorem. So in this maximum power transmission means here we can transmit from one place to another place, right. So we use this formula, right. 120 ohm resistor into 120 ohm, 120 into 120 by 120 plus 120. What is the resultant impedance means 60, right. We can calculate, it will get 60. So it will matches, right. Trans receiver is 60 and transmitting receiver is also 60. So there is no chance to mismatch the signal or bond to transmit with same frequency. Don't mismatching the frequency and don't mismatching the some noise, so signal transmissions. So that's why we are using 120 ohm resistor at both end in CAN protocol, okay. Next, here ECU is nothing but a node and CAN is nothing but a CAN bus, okay. Please remember this. Sometimes I'm using node, sometimes I'm using ECU, so both are same, okay. Next, CAN is a serial asynchronous non-return to zero protocol. Here, in this point, I will explain you clearly with example also. Okay, what is CAN serial asynchronous non-return to zero protocol means? It is a serial communication protocol. It will transmit one byte after one byte. Okay, it will transmit one byte after one byte means serial. Okay, it will transmit serially. Next, here coming to asynchronous means, here what is mean by asynchronous means, in the meaning of asynchronous, there is no involve of clock signal. So there is no external clock signal involves here. So it is based on time quanta. So it is the time quanta. The CAN units is nothing but a time quanta. We can call as time quanta. Here non-return to zero means the data will transmit continuously. How the data will transmit continuously? Here see 0 0 0 0 0 0 0. We are transmitting all zeros from 8 bits. Okay, when we are transmitting 8 bits as the same bits, the ECU will receiving. So what will happening in receiving time, it will take some continuous process. So it cannot allows another messages to transmit because the same data is same. So it will transmitting continuously. They didn't allow another data. So in that time we will getting the bit stuffing. This concept in this bit stuffing concept I will clearly explain you and another slide. Okay, please remember this bit stuffing. Okay, this is a bit stuffing. To avoiding this bit stuffing, we are using non return to zero. In the signal, like we are sending this signal, this is the 8-bit signal. Bit stuff is added after 5 consecutive zeros. Okay, make it to better synchronization. For example, when we are giving the continuous zeros, after the 5 consecutive bits, we will adding the bit stuffing. In this bit stuffing, what will happening means, when we are giving 5 continuous consecutive bits, after the 6th bit, we can inverse the 5th bit. For example, you are sending 5 zeros. So 6th bit will be 1. For example, of course, if you are sending 5 ones, after the 6th bit is 0. If you can give this type of synchronization, it will better understanding for the ECU. So this is the example for non-return to zero protocol. Okay, next. The main purpose of 120 ohm resistor I explained you. Okay, next. This is the CAN diagram. How the what are the means what are the nodes are there, how many nodes we can connect, what are the connections are there, what is the high and what is the low. Okay, how the transmission will happening in CAN bus. This is the diagrammatic for the CAN. So here what are the architecture and the standard ISO layers. Okay, this is the conventional network means we have the different types of ECUs here. So this is a conventional means the before the CAN we are using different wires, different connections from the ECUs. So plenty of wires. In olden vehicles we can see the connection between connections wiring system is very high. See, very high. Different types of wires are there. If you cut any wire from there, how can you find that? So it is a difficult to sort out the problem. So, but nowadays we are using CAN protocol. It has a two wires only. From every ECU, it have two wires. It will reduce the connections and it will reduce the problem solving also. So every ECU will have low and high. So every ECU will have low and high. Within a single bus, we can connect different ECUs. Here, see, your every ECU will connecting some different wiring systems, but here single wire different ECUs. Here different ECUs with different wires. So this to avoiding these different connections or mismatching connections. So to avoid this hardness of connecting wires or transmitting the data, to avoiding using CAN protocol to reduce the connections, reducing the difficulties. So we using CAN protocol. This is the architecture of CAN. Okay, so CAN have the different voltage levels. Okay, which is and also CAN has a parts which is a part A and part B. Which is standard by the standard CAN and extended CAN which has the frames which has a different frames in CAN. So now I am explaining. So voltages in CAN is a low voltage means 0. What are the CAN low voltage is 0. What are the CAN high voltage is 5 volts. It will have 5 volts is the maximum voltage of CAN. Okay. In in this CAN we have the dominant voltage and recessive voltage. Okay. And also act as a dominant voltage bit and recessive voltage bit is having. So in this CAN voltages, okay, in this CAN voltages we can have some communications or breaking commands. Okay, we have breaking commands, which is first I will explain what is the dominant bit. Dominant bit is nothing but 0 and recessive bit is nothing but 1. So every issue will understand or every computer will understand what zeros and ones concept, right? So here also we are following zeroth bit and 1th bit. So 0 and 1. So same here, whatever the computer language we are using here also computer language. So what is the dominant voltage of CAN means the dominant voltage is 1.5 to 3.5 volts. Okay, 1.5 volts to 3.5 volts as a dominant voltage. And what are the differential voltage of CAN means 2 volts. Okay, how can we calculate this differential voltage means? So we can, what is the highest voltage minus lowest voltage, we can get dominant voltage of differential voltage of CAN. Okay, what is recessive voltage? What is the differential between the recessive voltage means? Your recessive voltage is 2 volts or 2.5 volts. So the difference voltage is 0. For example, here the same highest voltage and lowest voltage is same for recessive bit. So we can get 0 volts. This is the recessive voltage. For example, I will give you for the example from these voltages when a break command is sent. For example, you send a break command, it is transmitted with dominant 0 bit. Okay, higher priority. For example, every CAN protocol will gives the higher priority based. Okay, so when we transmitting 0 is a higher priority for the higher priority from the CAN. Okay, higher dominant 0 bit higher priority over less critical signal like temperature updates. For example, I will give you one example. When your engine car engine is overheated, what will say they overheated? Okay, in this situation your infotainment will showing the signal your engine is heated, right? How it will shows? When the ECU will send the dominant, when dominant bit to the infotainment, it will display your message from the infotainment. So this is the example for voltages. Okay, here I put here the 11 bit identifier and 29 bit identifier, what is extended, what is, sorry. So I will explain you this in another video. Okay, what is the formats have can, or how many formats it have. So I will explain another video, guys. So this is about today. Okay, thank you for watching this video. If you have any doubt regarding this concept, please comment in comment section. I will reply your message. Okay, I will reply your comment and I will provide you the full guidance of that part. Okay, I will explain you once again. Okay, please comment in comment section. Okay, please like, share and subscribe my video. Thank you for watching this video.